What's up, guys? We're going to talk about solving systems with elimination. Eliminate means to get rid of something. So this strategy involves us getting rid of something to make it helpful to us. Okay, so keep that in mind as we go through. Your quick overview of the process. Okay, first thing you want is you want a zero pair with one of the variables. And so we're going to look at that. Remember, zero pair means equal and opposite. They add to zero, right? We're going to use least common multiples to make that happen. If you're not familiar with that, if you forgot what that means, I'll talk a little bit about it in this video. If you need more help, go YouTube it and see what you can find out, okay? Because you create the zero pair, which leaves one variable, so you solve for that one, take that value, substitute it into the other equation, find your other variable, okay? And of course we want to check, because checking is our way to know, boom, got it, or ooh, I need to go check my math. What happened, okay? Remember, a solution makes both of the equations in the system true at the same time. All right, so let's check this out. 7x plus 2y equals 24. 8x plus 2y equals 30. So we want to solve this system. When we're talking elimination, we want to see, are any of my variables a zero pair to start out with? Because I'm going to add my equations together. So I look and I see I have 7x and 8x. Well, 7x plus 8x, that's not 0x, right? And I look at 2y plus 2y, that would be 4y, not a zero pair. So right now, neither of my variables is a zero pair, okay? I could do the x's, right? If I find the least common multiple, and then I could see, like, what do I multiply by? But this time I'm looking at those y's because right now they have the same coefficient. And to make it a zero pair, I just need one of those to be negative. So what I'm going to do is multiply one of my equations by -1. Okay? And when I multiply it by the whole thing, we're maintaining equivalence because I'm manipulating the whole thing. Okay? So this is going to be -1 times every part of this top equation. So I'm going to have -7x minus 2y equals -24. Okay, the bottom one, I'm going to leave it alone because it's going to have that 2y, which is going to create a zero pair. So watch what happens. So I have 8x plus 2y equals 30. Okay, I'm going to add these equations together. This -2y plus 2y, that's my zero pair. That means I'm only left with x. Sweet, I get to solve for x, right? So -7x plus 8x is positive x, and -24 plus 30 is going to be positive 6. So hey, look at that. X should be 6. Sweet, loving it. Once I have that, I'm going to plug back into one of the original equations. Never do a manipulated one. Always, always, always go back to an original, right? So I could do 8x plus 2y equals 30. I could also use 7x plus 2y equals 24. Okay, either of the originals, we're going to substitute x for 6. Remember, substitute means they're equivalent so they can trade places, right? So 8 times 6 plus 2y equals 30. 48 plus 2y equals 30. All right, so we're solving for y. So get rid of that 48 by zero pairing, so subtract it. 2y equals -18, and now divide by the coefficient, so we get y equals -9. Okay, so I'm predicting that my solution should be 6, -9. But remember, we never celebrate until we've checked. So I'm going to check this, what I think it is, by substituting into both equations, because remember, if it's a solution, it has to make them both true statements, not just one. Always, always, always check both of them. Okay, so I'm going to plug 6 in for my x's and -9 for the y's. So 7 times 6 plus 2 times -9 equals 24, and I'm going to simplify. 42 minus 18 is 24, and I get 24 equals 24. Woohoo! Okay, one works. Check the other equation though before we have our total celebration here. So again, swapping the x and the y for the x and the y value. All right, so I get 48. This is negative 18. 48 minus 18 is 30, which equals 30. Woohoo! My solution was correct. Okay, so that's what we're doing with elimination. You want to create that zero pair to help you out so you can combine the equation. Let's try it again. All right, 6x plus 2y equals 30. 9x minus 4y equals 3. Okay, so again, look, are there any zero pairs already? Well, 6x plus 9x, that's 15x, not 0. 2y minus 4y, that's negative 2y, not 0. Okay, here I'm going to talk about this one a little bit more with those common multiples. I want you to see, so I could go for the x's. So I would look at the coefficients and I'm like, well, 6, 12, 18, 24, right? And keep going, going, going. Those are the multiples of 6. And then I could list the multiples of 9 till I see where they have one in common. So I could change the coefficient to 18 and make one of them negative, and I would have a zero pair. So I could change my x's. But then I can also look at the y values. So I have 2, 2, 4, 6, right? And then I have negative 4, okay? And I know they're not the same, but look, I have those 4s right there. So either way, I can either change my x's or I can change my y's. I want you guys to know that. You can change either one. I'm going to go with the y just because I just have to multiply one equation to make it a zero pair, right? Because if I multiply this top equation by 2, that's going to give me positive 4y, and positive 4y minus 4y will be my zero pair. So sweet, let's make that happen. So I'm multiplying everything in this equation by 2, okay? So it's going to become 12x plus 4y equals 60. And that bottom one, I'm leaving it alone. So it's going to be 9x minus 4y equals 3. And now I add my equations together. Okay, so I'm going to have 21x. And then I have no more y's because I zeroed them out, equals 63. Divide by the coefficient. I'm going to get x equals 3. Okay. Once I have that, I plug into either one of my original equations. So I can do 6x plus 2y equals 30. I could use 9x minus 4y equals 3. Okay, as long as it's the original, don't use the manipulated one. All right, so I'm going to swap my x for 3. So 6 times 3 now plus 2y equals 30. So I'm going to have 18 plus 2y equals 30. Solve for the y, so subtract 18. So that goes to 0. I have 2y equals 12. And divide by 2. So y equals 6. And guys, if any of your calculations stump you, you have a calculator, just pop it in. If you're like 30 minus 18, let me double check. Go for it, okay? Use your tools, be successful. Okay, so I am saying I believe my solution is 3, 6, but no celebrations till we do the check. Okay, so let's make sure when I plug this point into both equations, they're both true statements. Because if it only makes one true, whoa, I better go check my work. Okay, so I'm going to plug in 3 for the x's and 6 for the y's. 18 plus 12, does that equal 30? Sweet. All right, one equation works. Check the other though before you celebrate. You got to do it. I know you're like, that's a lot of math, but you got to do it. Okay, 27 minus 24. Is that 3? It is. Sweet. Now you can celebrate. Woohoo! I found my solution. Yay! Okay. All right. So it's finding that zero pair the first time using multiples, right? Okay, one more. Hang with me. Negative 2x minus 7y equals negative 13. 3x plus 6y equals 15. Okay, all right, here we go. So I'm looking for zero pairs. Negative 2x plus 3x, that's 1x, not 0. All right, negative 7y plus 6y, that's negative y. Okay, so neither one of them. And now I'm looking at them like, oh no, 2 can't multiply to become 3. 7 doesn't multiply to become 6, or 6 to 7. So let's check this out. So I'm going to look at my x ones first. So I'm going to have 2, then 4, 6, 8, right? 3, 6, 9. Hey, okay, they have 6 in common. So I could go to 6. I could multiply both to make them 6. Or I can look at the y values. I have 7, 14, 21, 28, 35, 42. I have 6, 12. Right, so you make the whole list. Finding when are they in common, and I can see, oh, okay, or I could multiply to make the y's the same. Okay, it doesn't matter which path you choose, you just got to choose one of them. Okay, I'm going to go with the x's this time. I'm going to make them into 6, and they already have opposite signs, -2 and +3, so I don't have to worry about the sign because they're already opposite. So I just need to make the coefficients equal. So I look at this one, I'm going for 6, so I multiply 2 by 3 to get to 6. And on the bottom one, I want that to be 6. Well, I multiply 3 times 2 to get to 6, okay? All right, so this time we have to multiply both equations. Here we go. The top one's going to become negative 6x, and then 3 times negative 7 is negative 21y, and then 3 times negative 13, that's going to be negative 39. Okay, now I multiply the bottom one. 2 times 3x, that's positive 6x. 2 times 6y, that's positive 12y. And then 2 times 15, that's going to be 30. Okay, I have my equal and opposites. There's my zero pair. My x's are gone. If you do elimination right, one of your variables should be 0. It's gone. You eliminated it. That's why it's called elimination. Okay. All right, so I'm left with y's. Negative 21y plus 12y is going to be negative 9y. And then negative 39 plus 30 is negative 9. Divide by the coefficient with the sign, guys. Don't lose your sign. So 1y equals positive 1. Okay. All right. Now I'm plug that into one of the originals, right? So negative 2x minus 7y equals negative 13. I could do 3x plus 6y equals 15. Just use one of the originals. Don't use the manipulated one. Okay. All right. So negative 2x minus 7 times, I'm replacing y with 1 because I said y should be 1. Okay, and now we solve for x. So negative 7 times 1 is negative 7. All right, solve for the x, so I need to isolate it. I get negative 2x equals negative 6, and x equals positive 3 because the negative divided by a negative. Again, if the calculations stump you, use the calculator. All right, so my prediction is that this is 3, 1 is the solution. So I check to see, does it actually make them both true? Has to make both equations true, guys, both of them, not just one. Checked them, it works out, both are true statements. Woo, celebration. My solution is the point 3, 1. That makes them both true. That would be the point of intersection. Guys, that's elimination. Go try it.